Hello cherubs, it's nice to see you again. Well, you can see me, but I can't see you. So this is a little bit awkward teaching to a camera. But hopefully I can teach you some stuff. I can do a little bit of chalk and talk. I'm going to miss your cheery faces and your cheeky comments. But hopefully as we continue doing this, it'll become a little bit more natural and a little bit more informative for you. But let's do the best that we can. First lesson I want to give you is a short lesson on calculating percentage composition. Percentage composition is quite important to be able to describe how much of a particular substance is in overall substance. For example, at the supermarket you might pick up something off the shelf and it says that it's 12.5% salt, it might be 35% or 40% sugar, it might have 7% fat or protein in it, and so we can describe the composition of something by its percentage composition. Let me give you a little bit of a reminder on percentages. Percentages part of 100, and so we can convert any fraction or any proportion into a decimal and change that into a percentage quite easily. The most common example of this that you would have come across is with a test score. Let's say, for example, that you have scored 45 out of 50 in a test. If we convert that to a decimal, that is 0.90, and if we were to multiply that by 100 or 101, that would be 90%. Very easy. If you were to have scored, for example, 8 out of 32, 8 out of 32 is a quarter, or 0.25. If we multiply that by 100 or 100 over 1, that is 25%. It's real easy to multiply by 100. You simply shift the decimal point 2 places. So we can change a fraction or a proportion into a decimal and then into a percentage. Let me give you an example with water. Water, H2O, we know that that has a molecular mass of 18. Hydrogen has a mass of 1, and there are 2 hydrogens, so the total mass of hydrogen in the water is 2. Oxygen is 16. So if we were to have a look at the oxygen percentage, that would be 16 out of the 18. The mass comes from the oxygen alone. If we convert 16 over 18 into a simplified fraction, that's going to be 8 over 9. And because I've learnt my fraction and decimal conversion, that is 0.8888. And if I multiply that by 100, simply shift the decimal point, that's going to be 88.9%. So 88.9% of water's mass is due to the oxygen. The hydrogen percentage is going to be the difference. So we're going to expect about 11.1. So 2 over the 18 mass comes from the hydrogen. 2 over 18 is the same over 1 over 9, that's 0.1111, or 11.1%. So you can see now that the total mass of water is 18, and you make a fraction, you divide the mass due to the particular element by the total mass. Let me give you another example. This time let's have a look at sodium carbonate. Now sodium carbonate has a molecular mass of 106 grams per mole. The hydrogen, whoops, there's no hydrogen in there. The sodium is 23. The carbon is 12. And the oxygen is 16. And we have 3 oxygens. So the total mass of oxygen is going to be 48. And we've got 2 sodiums. So the total mass of sodium is going to be 46. So the percentage of the sodium is 46 over 106. The carbon percentage is going to be 12 over 106. And the oxygen percentage is 48 over 106. Now you can put those into your calculator and push the button. Unfortunately, my calculator is on my phone, which is what I'm recording this on, so there you go. Very, very easy to do. So to summarise, the percentage composition is equal to the mass of the element divided by the mass of the molecule. And of course you multiply that by 100 to get it into a percentage. Really, really easy to do. I've given you a couple of problems to do just under this, so have a go at those. Take a photo of it and post it to me so I can see you're working as well as your answer. Have fun, my cherubs, and I'll see you again.